We're going to continue where we left off in the last one, which was that we were looking at these equations that have got surds involved with them, where we have to change the exponent on the left-hand side. Okay, an example was this one. Okay, let's have a look. 27, all right, 27, an example, to the power of 2/3 is equal to 9. How? Well, first of all, right, 27 to the power of 2/3. Let us simplify. We have to prove that. Let us say we have to prove it. We say, first of all, 27 to the power of 2 is 3 to the power of 3, okay, like so, to the power of 2/3, like so, correct? Now, let's have a look at the next one. We are now going to multiply out. So we've got 3 squared as our answer, so we're going to get a 9 over there, correct? That would have been the cube root of 27 squared, right? If I had to write it in surd form. So there's one where we've proved it equal to 9, right? But now we say, okay, be careful. I just want to do this one, so be careful. Because people say, okay, let us put in the fact that we've got, on the calculator, we said minus 27 to the power of 2/3. The calculator gives you minus 9. Why does the calculator give you minus 9? Because what it's assuming is minus 1 multiplied by 27 to the power of 2/3. That means it's giving me minus 1 times 9, which is the solution there, which is our minus 9. So please be careful, all right? If you're doing these and you've got a negative, put in minus 27 in brackets to the power of 2/3. The calculator will return you with an answer of 9. Okay? Be careful of that, because it can lead, well, it will lead to some pretty serious repercussions. Okay, let's have a look. Now we're going to put in a surd. We're going to put in x to the power of minus 3/4. X to the power of minus 3/4 minus 8 equals 0. Okay, pretty much we know that the 2's are going to be involved here, right, because of that. In this case here, let us take what we normally do and take the 8 to the other side. Let me just write this as an example. Okay, we take the 8 across. X to the power of minus 3/4 is equal to 8. Prime factor, okie dokie. Don't write 8 there, all right? We say x to the power of minus 3/4 is equal to 2 to the power of 3. Now what do I have to do? My next step is to say, okay, I don't want x to the power of that. So I'm going to take both sides and multiply by minus 4 over 3. Minus 4 over 3, okay? And what do I get then? Then I get the following, all right? Just move it down. Okay, I get x to the minus 4 over 3. Let's have a look here. This becomes x to the power of, multiply that out, cancels out, right? 3 and 3, 4 and 4. That's what I did, and I get x to the 1. That was my objective. Equal to 2 to the power of minus 4, which is x is equal to, that's a negative, make it positive. When it's positive, it goes underneath. 1 over 2 to the 4th, which is 1 over 16. Okay. Let's do another example. Here we've got one, x to the power of minus 2/3 minus 25 equals 0. Okay, right. Can you see we've got even exponent, right? We've got x to the, it's an even on top, it's a 2. Therefore, plus minus solutions. It's going to have a positive and a negative in the solution, isn't it? So therefore, x to the minus 2 over 3 is equal to 25. X to the minus 2 over 3 is equal to 5 squared. There's our prime factors. Now I want to get rid of that power there. So I say minus 3 over 2 to the minus 3 over 2. Now at this point, I say, okay, x to the power of 1 is going to be equal to plus minus 5 to the power of minus 3. Because I've accounted for my positive power here, which is going to be plus or minus 1 over 125, which is 1 over 5 cubed, is it not? So, please remember you check and see if you've got a positive exponent. If you've got a positive exponent, account for it by a plus or a minus root. Okay? Let's have a look at what if we've got something that looks like this. All right? All right, let's just get down on this page. What if I've got something like this? 5 to the power of 5x plus 7 x to the half minus 6 equals 0. That looks suspiciously like a trinomial, a quadratic, doesn't it? How would we check? What do we watch out for? We look out for this. Can you see there's a 1 there that's not written? This is in the ratio 2 is to 1. What is a quadratic in the ratio of? It's also 2 as to 1. So therefore, this is a quadratic equation. It doesn't look like it, okay? There's two ways of doing this, all right? First of all, we can say, well, it's a quadratic using 1 and its half there. So what we would do is we would make this like this. We could pretend, okay? But I don't like that. I prefer to say this is going to be 5 to the power of x to the, silly me, 5x to the power of a half, and over here, x to the power of a half. Why? Because when we multiply that out there, you are going to get 5x to the half times x to the half, which is 5x to the power of 1, right? And then we get a minus 3 and a plus 2 in there. And then we can solve, because we can say 5 to the power 5x to the half equals 3, and x to the half equals minus 2. Okay? X to the half equals minus 2. And we're going over here, we say, okay, now we want x. So first of all, I've got to say, take the 5 across to the other side. How? Divide by 5, because it's 5 times x. So I get x to the half equal to 3 over 5. What do I have to do? Square both sides. Right? I'm just going to put it in green. I'm going to square both sides now, and I end up with, whoops, sorry, not red, I don't want to use that one. I want to say x is equal to 3 over 5 squared, which is 9 over 25. And on the other side, I square again. Okay, green, let me square it. Square it, and we get a solution, x equals 4. Okay, all right. Now, how do we go? We say, okay, now we have to check the solutions. In a Surd equation, the last step is check your solution. Okay, how? Well, you go back to the top. You go back to the top. You go right-hand side, and I'm going to use this x first. I say that is 5 times 9 over 25 plus 7 times 9 over 25 to the power of a half minus 6. Let's see what this is. Well, what is that? 5 times 9 over 25, that becomes 9 over 5. Plus 7 times that becomes 7 times 3 over 5 minus 6. That's 9 over 5 plus 21 over 5 minus 6, which is equal to let's shift this just up a bit. That is equal to 30 over 5 minus 6. 6 minus 6 is equal to 0, is equal to the right-hand side. Therefore, x equals 9 over 25 is a valid solution to that equation. Right? Moving up, now we have to try x equals 4. So let's put x equals 4 in. Try x equals 4. Let's go. That is 5 times 4 plus 7 times 4 to the power of a half minus 6 equals 0. 5 times 4, 20. 7 times that is 7 times 2 minus 6. Sorry, I shouldn't put in there equals 0 because that's what we're doing. We're just doing left-hand side first, right? And we get 20 plus, we get 20 plus 14 minus 6. That is not going to be equal to, because that's going to be 20 minus 6 is 14 equals 28. It's not equal to 0. Therefore, 4 is not a solution. Now, those of you who are quite astute would have noticed that here I had something that I'm going to do in a different color. I'm going to do it in red. 5 times 4 plus 7 times 4 to the half minus 6. That is 20 plus. I chose here, remember, I said square root of 4 is 2. But it could also be, you could argue, minus 2, which means 20 minus 14 minus 6, which is equal to 0. So you could say, but then 4 must be a solution. No, it's not, because it has given us the option, correct. The minus 4 worked, but the plus 4, or sorry, the minus 2, or the plus 2 didn't work. So one of the things, it has the square root in it. It doesn't actually work because it gives 2 answers. And if one of those answers is not valid, we can't use it. Because what it means is that we are then saying that this one must also be true. So you can't be selective by just saying the one is true in these kinds of equations. So that is that one. I'm now going to do, I want to just look at another way of doing it very quickly. I'm going to do a whole section on this, all right? But just for starters, let's have a look, okay? 5 to the power of x. This is called the K method. Okay? We're going to do a session on the K method on its own. 5 to the power of x plus 7 to the power of 7 to the power x to the power of a half minus 6 is equal to 0. I can notice here, okay, 5 x to the power of 1, okay, not to the power of x. Okay, this is to the 1. So I notice, first of all, there's a ratio 2 as to 1 over there, which indicates it's a quadratic. The K method says substitute. It's a method of substitution. What do? I say up front, let K equal x to the power of a half. Therefore, 5 plus 7k minus 6 is 0. What goes here? Therefore, k squared is equal to x. Isn't it? I'm just changing it into a normal trinomial, quadratic, that I'm used to. Then I solve, and I say, okay, you are 5k minus 3, and you are k plus 2 equals 0, which gives me k equals to 3 over 5, and k equals minus 2. Now when we get to this point, We've got k, but we want x. So what do? We replace k with the original substitution. So we say, right, k was a half. Look, so now I can say, therefore x to the half is going to be 3 over 5, and x to the half is going to be minus 2. Minus 2. Next, then I say, therefore, x, square both sides, 9 over 25, x is equal to 4. And then we go and we test answers. That is the K method. As I say, there's a whole section where we're going to just do just the K method on its own. Here's a surd equation now where there's an actual surd in it. Let's say they ask us simplify this, right? Simplify, hang on, let me just move this out the way. Simplify 6 times root of 4x to the power of 12, okay, minus 32x to the 12. Whoops. X to the 12. All over 16x to the 12 and root that. X to the 12. X to the 12, right? So that's our formula. Okay, what are we going to do? First of all, prime factor. Okay, number 1, PF. Prime factor, all right? Just inside the surd. Just inside the surd initially, you'll see why. 6 times the square root of 2 squared x to the 12 minus 2 to the 5 x to the 12 there. All over the square root of 2 to the 4 x to the 12. That was step 1, writing prime factors. Step 2, okay, change surd to exponent. Therefore, that is 6 times 2 squared x to the 12 to the power of a half minus 2 to the 5 x to the 12 all to the half. Next is 2 to the 4 x to the 12 to the power of a half. All we've done there is we've just changed it into exponential, right? Why? Well, so that I can work with it. Now, the next step was going to be, next was, I've got how many? 1, 2, let's call it step 3. Okay, let me just move you down a little bit. Step 3 is going to be remove the brackets again. So this becomes 6 times, we multiply in 2 to the power of a half times 2 over 1. X to the power of 12 over 1 times 1 over 2. Minus 2 to the power of 5 over 2. X to the power of 6. 2 to the power of 2. X to the power of 6. Okay, hopefully you saw that. I've just done those without writing it all out. The net result is we end up with 6 times 2 to the power of 1, correct? 6 times 2 to the power of 1, x to the power of 6, minus 2 to the 5 over 2, x to the 6, and 2 to the 2, x to the 6th. Okay, remember now this had a plus minus. Look, there it is. Did you see it? What does that tell me I must do? It tells me I have to factorize. Therefore, I take out the common factor. Well, first of all, I can say, okay, look, let's say I'm a bit confused about the numbers, so I take out x to the 6, right? X to the 6, leaving us with a 6 times a 2 minus 2 to the 5 over 2. All right? And at the bottom, that is 2 to the 2, x to the 6th. So we can take out and start then, remember, cross-cancel again and simplify. Right? That's what we do. Here we are going to cancel and simplify. Cancel out to simplify. The x to the 6 cancels. Right? So that's what we've got. We've got 6 times 2 minus 2 to the power of 5 over 2 all over 2 squared. Now, we can't do that without a calculator, and they've asked us without a calculator to do this. What we do is we take this one where it's an improper fraction. You take your 2 to the power of 5 over 2, change it back to a mixed number. What is it? It's 2 to the power of 2 times a half. Correct? There we go. 2 times 2 is 4, plus 1 is 5. Let's say it was 2 to the power of 7 over 2. That would be 2 to the power of 3 times a half, wouldn't it? Because 6, 7. This is the same as 2 squared root 2. This is 2 cubed root 2, is it not? So what are we going to do now? Well, I am going to change that one to 2 to the 3 a half, because that is the same as, let's put it down, is equal to 6 is 2 times 3 times 2, minus 2 to the power of 2, 2 to the power of a half, all over 2 to the power of 2. Can you see what happens now? Okay. We've dealt with this fraction differently. Look at the top. I've got, oh, hang on, we've got 2 times 2. So we've got a factor of 2 that we can take out there on top, which we forgot. So it doesn't matter if you don't get it first time round. Just keep going and recognize that there are going to, in all likelihood, be more factors on top. So you change that to that. Therefore, we can take out 2 squared. And we end up with 3 minus 2 to the there over 2 to the power of 2. And that cancels, and we end up with 3 minus 2 to the half, which is equal to, if you like, 3 minus root 2. Cool. Okay. 3 minus root 2 is the answer to that guy. So what did I do different? I haven't done anything differently here. Okay. All I've done is exactly the same as previous. Okay. I've done exactly the same as we've done before. Okay. Whereby we have taken the prime factors, we've changed the surd into an exponent this time. Multiply out the brackets, split if necessary, factorize if, can you see, it's the same old wash as we say in this house, wash, rinse, repeat. Here's an old, these are old favorites that you get. They ask you, simplify the following, okay? This is another example of exponents and surds. 10 to the power of 2009 and the square root of that, all over 10 to the power of 2011 minus root 10 to the power of 2007. These are favorites, right? The recipe is the same. No, your calculator can't do that for you, right? So what do we do? In this case, can you see, they have given us all of these in the same base. So therefore, you don't need to prime factor the base. If the bases are different, you can prime factor. But in this case, don't. Okay? So let us just see, what is the recipe? Well, the first thing, what we said is, we said, right, write them all, change this to an exponent. Well, let's do that. That is 10 to the power of 2009 all to the half, divided by 10 to the 2011 to the power of a half, minus 10 to the power of 2007 to the power of 2. Now you say to me, okay, fair enough, I understand that. Therefore, what do we do next? Well, the next step we're going to do is I'm going to just roll that down so I can copy it down. Put the thing in. That becomes 10 to the power of what? Okay, that becomes 10 to the, on top, 10 to the power of 1004. Correct? 2009. Let's just see. 2009 divided by 2 is going to be 1004.5. All right? If you used a calculator. If you don't, you're going to get this. 2009 over 2. Here, this is going to be 10 to the power of 2011. Sorry, my bad there. 2011 over 2 minus 10 to the power of 2007 over 2. Now, what did we say? We said, okay, let us change them. Change to, change to a mixed number. Right? Let's change them to a mixed number quickly. We're almost there at the end. That is going to be 10 to the power of 1004 times 10 to the half. Over here, this is going to be 10 to the power of 1005. 10 to the half. Minus 10 to the 1003 times 10 to the half. Okay. All I did is I basically divided them. For example, 2011 over 2 divided by 2 is, not times, sorry, it's going to be 1003 divided by 2 is going to be that SD 501 and a half, right? If I took that 2010 to the power of 2007, 7 divided by 2, okay, is that 2007 over 2, SD 1003 and a half. Let's just do it. 10 to the power of 2003 is equal to 10 to the power of, sorry, it's 2007, my bad. 2007 over 2 is 10 to the power of 1003 and a half, which is 10 to the power of 1003, 10 to the power of a half, which is root 10. Like that, right? That's where it comes from. So I've just manipulated it to be that. Then for those of you who are looking, there's a minus, which means we've got to factorize. Let us factorize and come to the end of this one. Factorizing on the bottom, I say I have got here, this is 10 to the power of 1004 times 10 to the power of a half. Never mind that dot there. All over, not using the eraser, factorize 10 to the power of 1003 leaves me with 10 to the power of 2, 10 to the power of a half, minus 10 to the power of a half. This cancels out over here, leaving us on top with a 10. Okay, 1003, there we go, leaving us with a 10 on top there. 10 to the power of 1, correct? 1004 minus 1003. And lastly, we say, okay, you're gone. Now we've got a much easier thing to look at. We have got 10, like this. We've got 10, okay, times 10 to the half over 10 squared times 10 to the half minus 10 to the half. But hold on, there's another factor here, guys. Look, that is 10 times 10 to the half. I could have taken out that 10 to the half, leaving me with 10 squared minus 1. That's then going to cancel. There, and it leaves us finally with 10 over 99. Okay. That was quite a complicated, it is quite a complicated one. It's a favorite. Please just note the recipe that we used there, right? You look, you expand you take it out into the exponent, move it in, convert it from a, whatever it is, something over 3, convert it to a whole number and your fraction. Factorize, cancel out the big numbers, and it leaves you with small numbers that you can work with. If you don't get the highest common factor first time round, don't worry, you'll get it in the second time round. Okay? Thanks for watching. The next one is going to be on, we're going to do surd equations. I'm going to do another example like that using a plus and a minus on the top and the bottom as well. And then we're going to do surd equations. Okay? And yep, that'll be that. Thanks for watching. I'll see you in the next session. Cheers. Bye.